All right, welcome to another video here. Today I wanted to talk a little bit about making miniature um, uh, a miniature chatbot that's inspired by ChatGPT. Many of you have likely seen some of the articles over the past month or so, with all the of the hype that was driven by ChatGPT, and it's been kind of amusing for me because you know, 2 months ago I thought that the hype cycle for AI and machine learning had peaked, maybe to 2019, maybe even 2018, just before just before the just before COVID, just before interest rates rising, and before Nvidia stock kind of took a bit of a dive with um, devaluation with crypto mining. But I digress a little bit. There's a lot of interest in building something, and I wanted to try and put together something that I'm going to call building a mini GPT in a week of lunches. There's a book called Learn Rust in a Month of Lunches by David McLeod. Credit him. I love the idea of trying to take a dense topic and package it off in bite-sized pizzas. No pun intended. To say, in so many lunches you can tackle this. And so this is intended to be an example where we will build a mini GPT, if you will, in a week of lunches. And by that I mean 7 videos or fewer, 30 minutes, 40 minutes or less in each video. So the thing we're going to be building here, I'll show it to you first, and then we'll work up to it together. So this is a page here. It's running here locally, but we'll deploy it online. That has chatbot like functionality. You can ask it questions. And sometimes the answers are, kind of make sense. What does Starbucks sell? They sell coffee. What is the capital of Germany? Yeah, that's not too bad. But sometimes it gets confused. So let's think of something. Let's say, how can I make coffee sweeter? That's not a particularly good answer. Let's try, what is bread made of? Okay, maybe this isn't quite so bad. But these are a few examples, some of them vaguely insightful, some of them a little bit silly. But it's a chatbot functionality. The answers are intriguing oftentimes, and it's a reasonably slick online web interface. And I wanted to put this together because a lot of the tutorials will be simply confined to a Jupyter notebook or perhaps one or two Python files. And one thing which can be frustrating if you're getting started is wanting to share your work with the world without having to say, go and let me go get my laptop. That feels rather clunky. And so taking some of that functionality and then putting a little web page around it makes it look a lot slicker, but also opens it up to a much broader audience. And I wanted to make one comment on the philosophy that, at least for me, has been helpful in taking when trying to learn some of the elements of putting together a computer science type project. Lots of people talk about how you want to read the documentation, read the literature, study what you're doing, and there's a temptation to just copy and paste from Stack Overflow instead. Now, that's obviously not a best practice to learn things, but in some of these sessions, we will be doing a little bit of copying and pasting. And in fact, this model, if you will, is a model which was generated by Microsoft, and we have copied that model, if you will, and we're now deploying it in this little application. Um, but that begs the question: is it better for you to try and learn that particular element from scratch, where the neural networks that do that are fairly complex beasts to try and get your hands around the first time, or is it better to acknowledge that there are experts that do that and put the rest together in a way that brings the most value? I wanted to put together one little chart that I think might help to explain some of the benefit of being willing to take a couple shortcuts to get started and then go back and learn the details later. Because just to build a fairly simple web application like this, there are so many pieces of it that go together. You'll have a server someplace with a database. Turn the application, that might be a second server. You'll have to have an operating system. Oftentimes, the application itself will run in Docker or in Kubernetes. Within that, you'll have, in this example, Python, a common application, a common language. The Transformers library for machine learning that's built on top of that. There will be a backend written in Go or Rust or Java or whatever language you so choose. HTML to make the page, JavaScript to animate the page, a web server like Apache or Nginx to serve the pages, and then you've got to register a domain. You've got to go to Cloudflare or to Google or someplace like that. You've got to make a certificate. And one thing which I think has, for me, been particularly frustrating in the past is even when I felt like I did an honest and sincere job trying to learn one or two of these elements, when you go to put it all together, it's getting the plumbing right that often was the most difficult part. It was getting the HTML to load the JavaScript properly from Nginx, or it was getting Python to talk to Nginx, or it was getting Docker not to have some issue with file permissions on Ubuntu. Those are the places that I got tripped up the most. And it felt particularly frustrating because I hadn't tried to take any shortcuts. I was trying to learn things, and it was the edge cases that I felt like were being particularly troublesome. So I think that for being able to say, look, I did something, I can point to it, I can show you. To copy and paste some of those things is not always a bad thing. You want to go back and learn it, go back and then understand it better. But oftentimes I find myself saying, I want to find that there's some path. I want to make sure that if I'm trying to chart this landscape of what the technology stack could or should look like, I want to make sure that I can traverse it. And yes, you want it to scale more in the future. It's not going to be perfect. But I want to make sure that I can connect those dots along this path in a way that works, so that I don't spend all this time learning one particular paradigm, one particular language, one particular framework, only to find, oh, that's never going to play nicely with some other element. You have made a fundamental mistake 2 weeks ago. I think that to be able to see, I'm onto something, it needs work, but there's proof of concept here, and there's proof of the viability of a given approach, that goes a long ways. And for all the times that people talk about the difficulty with imposter syndrome coming into the tech space, being able to say that these parts fit together, I'm going to focus on learning one of them in more detail, perhaps each week or each month, but I can plug them together in a way that makes something that works, that has a lot of value. So with that, let's get started. And the first thing we'll do today is we're going to spin up a instance of a very small virtual machine in the cloud. And this is because if you are going to host a web page, web pages live on servers, so we need a server. There are several different places you can go to do that. Vultr is a common one. Another one is Contabo. I've used them as well. Linode, I've used them as well. SSD nodes, and there's others that I've also used. They're all very good. They all have competitive pricing. Those are an easier place to start if you're just getting started. For many applications, as the scale and complexity grows, you may well want to move to a cloud provider like Amazon Web Services or Google Cloud or Microsoft Azure. But just to get started and kind of crawl before you walk, these are a good place to start. And so, as an example, I'm going to do the Vultr just because it's one that I use more often than some, and I've already got an account all set up. So if you go to the Vultr page, obviously you'll have to create an account. These are things that do cost some money, so you'll need to give it a credit card. But the cost should be fairly modest if you don't over provision and if you shut things down that you're not using. So in this example, let's say you want to get started from complete scratch. You don't have any infrastructure, don't have any code. We'll start by spinning up one Linux box, and that'll be a place to start. So let's go to, we're at the products page, click on the plus button, and we're going to deploy a new server. The cloud compute is generally the most economical of these, so we will do that category. The CPU you use shouldn't matter that much. I'm going to go with the base model. Intel regular performance, nothing fancy. The USD you pick shouldn't matter that much. Some of them have fewer features or fewer types depending upon what they've got set up locally. I'll do Atlanta in this case. The selection doesn't matter. Again, doesn't matter that much. I'm going to do Ubuntu. It's a popular operating system. It's the one that I know the best personally. I'll do the 22.04 LTS, so we've got a long-term version. And now on the server size, I am going to do this one here, the one vCPU, 2 gigabytes of memory for $10 a month. This is something which, if you're trying to just get started, hopefully the $10 a month is a price point that is less than most of the options out there. And the 2 gigabytes of memory, I think, will be just barely enough to get the model we want to fit there. For bigger models, you'd obviously need more, but this is about as small as you can go. But I think that the smaller one with 1 gigabyte will be too small to get the model to fit. So we'll do this one. I'm not going to do auto backups. That's the best practice, but I'm just doing this as a bare bones way to get started. And let's call this a demo because it's for demonstration purposes. All right. So that's going to start to spin up. Now the next step, once it gets instantiated, is you'll want to go in and do some very minimal steps to harden it a little bit so that it is more secure. And please, take this on the context that this is not a class on hardening Linux and all the aspects of security, but there's a few simple things we can do to at least reduce the attack surface a little bit, and we should always do that as a first step when we're spinning up something out online. So I'm going to pause here for a minute while this finishes instantiating, and we'll come back and pick it up from there. Alright, so I went and got a glass of water and took a couple of minutes, and now this instance is ready. So let's go here. Let's go to this instance, and we'll get some information on how to log in. So it's going to give us the IP address and the root username and the password. So I currently am on a our laptop that has Linux. The steps I'm going to do are pretty simple from the Linux terminal. Some of you may be doing this or following along from a Windows machine. The equivalent tool on Windows is called Putty. So if you do Vultr SHH, I think there's an article. Here you go. How to connect to a Linux cloud server from your Windows desktop. So this is the one thing that I would not be able to walk you through here online, because this is the machine that I've got here is it's Linux. But I've used Putty in the past. It tends to be reasonably easy to use. So if you are following along on a Linux machine, on a Windows machine, this is the one thing you'll need to go and take a look at. That'll be different from what I'm showing you. But as soon as you do that step and then are operating something that is on the server, everything will be the same from there. So let's SSH in here from Linux. So SSH root at, we'll copy the IP address. It doesn't know the IP address. It's not recognized. It's a new one. We'll type yes. Now we will copy and paste the password in here. So if you notice, we named the machine demo. This is now root user at demo. So this is now what we're assuming here is on the Linux server in the cloud. The first step I typically do is to update and upgrade the packages so that any security patches that have been applied since the date that this image was created from the install, those can be applied. So you do apt get update and apt get upgrade. Update updates the list of available packages. Upgrade upgrades them. And because getback means that it requires typically it requires a new version of a package, sometimes upstream. I'll add the flag with new packages upgrade. That may or may not install more. Okay, it didn't need to. So that's all up to date. Now we'll want to make a user besides root. For security purposes, so that you should use root as little as possible. So I will add user. Create a password. Don't need any of those. And then I'm going to add the Alexander user to the sudo group so that it has privileged access to do updates, install software, and things like that as need be. Okay, so that's done. The next thing is to harden the SSH access. So first let's make sure that we can get in as the user we created. So if I do SSH, but this time instead of root, I'm going to do Alexander. And I will put in the IP address. I'll put in the new password that I created. Great. So I can still get in. I can get in with the new account that I created. Sorry, the new user. But I still need to go and edit it so that you can't SSH as root. So we'll do. I think it's under SSH. I think it's SSH config that we have to edit to change what you can log in. How it authenticates and accepts users trying to log in. So the top thing we need to change here is where it says permit root login. Change that to no. And there's other changes you probably could make to harden it a little bit additionally, but that'll be a good place to start. The one other thing that I like to do to help the sessions stay alive a bit longer is I will set the TCP keep alive to yes, the client alive interval, which basically has the sends a message every 60 seconds if there's nothing going on, just to help keep the connection alive, and do that in a max of maybe 120 times. And that's just to help things not freeze and hang. If you are working on something, you step away for half an hour or so, then come back, it makes it less likely that it's going to go in and have issues. So save and close that, then do restart. Now if I log out and try to log in again, it shouldn't let me. I'll put in my password again. And it won't let me. So this is what we were hoping would happen. We have the same username, the same password we tried previously, and it's not working. And that's what we want. And we did try three times in a row, it kicked us out. So that's exactly what we want. But notice if we use the non-root user, we can still get in. And start to do things from there. The one last thing that I will do is I'm going to reboot the machine because it's had new packages installed. We want those to get applied. And so this is something that you don't want to have to do all the time, but with the new machine we should do it now. So I don't need to write sudo because this is a non-root user. Apply the password again, and it'll reboot. And we now have a way to get into a Linux box that's small, but should be enough to host a very small, minimal web page. And we will start to write the code and develop it further here in the next session.